Alright, for our next little game, we're going to do a 2D Space Invaders type shooter. And this is, we're going to learn how to control characters moving back and forth on the screen. We're going to do some work with audio. We're going to spawn missiles and have them, fire off. And we'll delete the missiles when they get out of the scene so we don't have any leaks. And yeah, that's about it. So here's what it's going to look like. We've got our guys up here at the top that we want to shoot, and then by hitting the space bar, so we are shooting missiles and detecting collisions, and then we're playing a little animation of the star going back and forth. That's going to show us, like an explosion. You can play whatever kind of animation you want, but right now we're just using the star because I think it looks kind of cool. And that's it. So that's what we're going to make. We're going to start from the very beginning from scratch and go through all of it. We'll probably go through some of the beginning parts pretty quick because I think everybody already knows how to do that. And if you don't know how to build animations from sprite sheets, then watch some of the other tutorials. We will be using more Glitch the Game assets. So you can use the same ones I'm using, or you can choose your own. It doesn't matter. But yeah, so this is what we're going to do next. We're going to do a little Space Invaders type shooter. Alright, so we'll start a new project. We will call it Shooter 2. And make sure we select our 2D defaults. And here we go. If we run, we've got our nice blue background here. And so what I'm going to do is start putting in some graphics. And we'll start with our little guy, which is a frog. So select over here, drag in our frog guy. And here he is with multiple frames. So we are going to say he's multiple. Let's go to our sprite editor and slice him up. Automatic. That's good. Now we can add him to our scene, and we'll just call him Frog. And if we run, maybe we'll see him. There he is. Alright, he's not animating or anything, but that's alright. We will change that real quick. So let's add a component, miscellaneous animator. We'll create a new animator controller. We'll call it Frog Animator Controller. And we'll assign it to our frog. Here it goes. Then we will open up our animation window. Dock it up here. I don't know why it's not up there. It usually is, but that's alright. And with our frog selected, we will add in the frames. And we will call it Frog Animation. There we go. And now if we run, he should be doing something. There's his propeller spinning. That looks awesome. It's a little small. So let's just make him a little bit bigger. Maybe that's too big? I don't know. Yeah, that looks pretty good. So there he is, just kind of chilling there, playing his little spinny propeller head. And let's give him some actions. We want to be able to move him left and right. That's the idea. Anyways, so let's create a script. We'll call it Frog Controller. And we'll add it to our frog. There it goes. And let's edit this thing. And so we will say, we want to just check, for right now, we'll just check left and right. And we'll add the spacebar later to shoot some missiles. So we will say if input.get key code dot left arrow. We'll say move left. if input dot get key code dot right arrow. We will move right, and we'll have our void move left, void move right, and in here we will, you know, all we really need to do, we're not doing anything crazy with these movements, because that's not really the point of this. The whole point of this one is to show how to shoot missiles and play animations when there's a collision, to give a, you know, sort of fake AI to our characters when they move back and left and right on their own. And so that's the whole point of this. We're not going to do anything fancy with movements. So we can just say vector3 position equals transform dot position and position dot x minus equals moving left, so we're going to go the other way. We'll say horizontal speed, and then transform dot position equals position. And we'll do the same thing for moving right, and we will say plus equals, and we need to define what that is. Equals, I can't remember what a good number for this is, so we will just start out at 1. And I think that should move our guy left and right. Let's see what happens if we run. Whoa, 1's way too big. That's all right. We made them public, so we can say 0.5. That worked better. Oh, still a little fast. About 0.25. There you go. That's better. So there he is, moving left and right. He goes off screen, but that's all right. Gonna move him down just a little bit. There he is. All right, so there he is, moving left and right. That is good. Not a huge fan of this blue background. We're a space shooter. We're a frog guy with a propeller head in space. So let's just switch that to black. Maybe later we'll add some stars. I don't know. Here he is. There's our frog guy. Propeller head, and he is ready to shoot some things. So a couple things that we need to do is we need to add things for him to shoot. And let's add in, and we also need to add missiles and things like that. But let's just add in something for him to shoot. So I've got these things here, a little crafty bot. I'll bring that in, multiple. It's got a little animation with it, so let's slice it up. Looks good. Apply. And create an object of him. There he is, looking good. Just call him Crafty. And I don't know, Crafty is the name that his asset was inside of Glitch. That's his file name, so Crafty sounds good to me. Let's make him animate, miscellaneous, animator, let's create animator controller. We'll call it Crafty animator. Something like that, and let's apply that here. So that's good. Let's go to our crafty animation window, which is currently empty, and we'll just grab all of our frames, drag it in. This is crafty animation, and if we run, we should see him doing something or standing still. What did we forget? Oh. Where did I put that? Oh, I had main camera selected, and I added our crafty animation to it. So that is not what we wanted to do. Let's remove this property. I Alright, well, let's just add another one here. Maybe this is going to work out okay, I don't know. Put it up. Make sure we have our frog selected. I'm going to overwrite our crafty animation. Is that going to work? There he goes. Ah, there he is. Spinning his head around and looking real good. So the idea is, in Space Invaders, we're going to have like a whole rectangle of these things, or maybe like a smaller rectangle, but they're going to move all the way to the left and then turn all the way to the right. And that's what they do. So what we want to do is let's just make this one guy move all the way left and right, and we'll set up his intelligence that he's going to move left and right, and then we can work on it later on, adding more of them. All right, so let's see. Let's go back to our scene, and here's our guy. We will need to add a C# script called crafty controller. And what that's going to do is make him move left and right. Let's take a look at this. Here's our camera. So let's say if we want him to go all the way to the left, and so he's about at -6. And then when he goes all the way to the right, he'll be over here at like +6. So again, I was just looking over here at the position of this thing. We know we want him to go back and forth, and so we're just going to start him at -6 or at +6 and go to -6. Now he's facing this way, so we're just going to start him off going to the left, and that will be good. So it's kind of similar, in our frog controller. In update we check and see, if there's any keys being pressed. If there are, then we move. In our self-controlled little bot here, we don't need to check for keyboards because we know where he's going, so we can just move him. But what we do need to know is his direction. So we'll say public int direction equals -1. -1 means we're going to the left. So then inside of update, we will say vector3 position equals new vector3. No. Equals transform.position. Right, and then we will say position.x plus equals direction times horizontal speed. And then transform dot position equals position. All right, does that make sense? And then so we need to have a couple things up here: public float horizontal speed. We'll probably need to have a public float min x. Let's set it to 0. Public float min max x. So these values here are going to determine how far left and right our little bot goes. So after we assign the position here, we can say if position.x is less than our min x direction times equals -1, and we'll also say or position.x is greater than max x. All right, so we're just saying if we're outside of our ranges, we're going to flip our direction. And now if we go back into Unity, we can see our little crafty bot. He needs our crafty script. And direction, horizontal speed, we'll just guess with 0.25. Min x we said was -6.0, max x was 6.0, and what happens? Oh man, nothing good. So he's stuck over here on the side. What did we do? Min x, max x, something really bad happened. Position.x plus equals direction times horizontal speed. So our direction is -1 times horizontal speed position dot x is less than min x. Well, you know what? Let's try and troubleshoot this a little bit. I can't see what it's actually doing, so let's just remove the flip and what is going on here. There he goes. Well, that's right. Why does he get stuck at the edge? Our frog. Well, we're starting him way outside the scope. Here, let's move him in here. Let's see if that makes any difference. All right, there we go. So yeah, the problem was I had him starting outside of the range, and so you know, the code isn't the best, but it gets the point across. And so we had him starting over here, and it was getting confused. It was trying to go left and right, left and right, left and right, left and right. So now that we stuck him in the right range, he started out okay, and everything looks fine. It is kind of fine, but we want to flip his scale as well. So when we change direction, we want to do something like, let's flip his scale so that he's facing the right direction. So if we say vector 3 scale equals transform dot local scale, and we'll say scale dot x times equals -1, and we will say transform dot local scale equals scale. And what does that do? There he goes. So now he's facing left and right, and yeah, there's probably like a frame where he's going the wrong direction. You know, he's going backwards and facing the other one, kind of moonwalking, but that's all right. We can't tell. He is going way too fast though. This is going to be sort of a challenge to hit. So I'm going to change his speed just a little bit. Make it like 0.1. There he goes. And now it's going to make it easier for us to actually shoot this guy. All right, so that's probably the first milestone that we have. We've got a character on the screen who is in control of himself. He is determining to go left and right and bounce off these walls, and we're not doing it. So that's something new that we haven't done before, and I think that's a good place to take a break right now, and then we'll come back and we'll start trying to shoot this guy and add more of them, and all sorts of fun stuff. All right, so we've got our little bot here, and he's running back and forth. And what we want to do now is add more of these things to it. And so we can start by just copy and pasting if we want. Or I'm just going to put them, I don't know, roughly align these things. And then if we run, oh, well, it's kind of a neat effect. Not exactly what we want, right? We want to have it, as soon as one gets to the edge, we want all of them to go back. Not the sort of follow the leader thing, although it does look kind of neat, but that's not what happens in Space Mater. So we're going to fix that. And basically what we want to have happen is as soon as one guy hits the edge, we want all of them to turn at the same time. And then as soon as one guy hits this edge, we want all of them to turn the other way. And so we're going to do that with a game controller like we've done in the past. So we will create game object, create empty. We will call him game controller. And we're going to create a game controller script who's going to be in charge of kind of directing all of these items. You know, tell them if they need to be going left or right. And so it will have a public int direction, which we'll set to -1, which because right now everybody's facing left, and we don't actually need to do anything in any of these. Just delete them. But we can have a public void reverse direction. and we will say direction times equals -1. So it's just going to reverse our direction, and that's it. Just like we had in our crafty controller, this kind of business, we will not do that here. We'll make the determination that, hey, we're too far, and so we're going to just want to call our game controller dot reverse direction. Right, that's essentially what we want to do, and oops, this should be just GC. Yeah. All right, yeah. So that's what we want to do. Is we want to actually call our game controller. So if we have up here a public game controller GC, then we'll go assign it in our GUI. But basically, we just want to call here and say reverse direction, and then when we're doing here this direction, instead of using our local direction, which we're going to delete, we will use our GC dot direction. And let's say, actually in here, we can say these transforms. So we don't really know, because one of our bots may decide it's time to change direction, and then we're all going to go. So we don't necessarily know each individual bot isn't making the decision to reverse direction. If that makes any sense, I'm going to just comment this part out down here as far as dealing with the scaling. And we'll fix that in a sec. Let's see, it'll probably make more sense if we do it this way. Blah, 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 blah. Looks good to me. So we're going to call reverse direction. We're using the GC direction. And all we need to do is go link this stuff up to all of our crafty bots. Now there is a game controller here. Let's just pull them in. This one, down. This one, down. So they're all referencing the same game controller object. There we go. And I think if we run, let's see what happens. There. So now, instead of doing that follow the leader business, they are just bouncing back and forth. They're not changing direction, so we're just going to go fix that real quick. And we'll just stick that inside of update. I'm going to pull this stuff out of here and say something like this. Scale equals transform local scale. Scale dot x equals -1 times GC dot direction. So we're kind of backwards. And do that, and that should work. Let's see. Whoa. Huh. That's interesting. What the heck? Should be -1 times GC dot direction. We do this. I think this should make it backwards. Yeah. Oh, I think I had it. Oh, I see. I had I had a times equals in there. No big deal. We want to say -1 times. There we go. Much better. Now let's see what happens. Perfect. So now we've got our guys going back and forth and back and forth. And this, isn't going to be exactly right, but it's going to be close enough. You see that there is some sort of spacing happening here, and that's okay. It's basically because of how the update method's getting called in all these objects, that some of them are going to be changing direction before other ones were, and you'll be off by just 1 frame, but over time, it's going to add up to a big distance. We could fix that later, but I don't really think we need to. Not for what we're trying to do. Which is make a fun little shooter game. All right. So that's exciting. Here we can put these more. We can put them closer together, and it'll delay the problem. It'll still be there, but yeah. Okay, so a fixable thing, but that's okay. We're not too concerned about it. So we've got our objects going back and forth, and we can just keep adding more of these to it if we want to. Just copy all of those. And now we've got a series of them. And let's just do this. That should be enough. Yeah. There we go. Looks pretty good. Now all we got to do is shoot these things out of the sky. So we are going to do that. One thing that we can do easily is add in the controls for it. If we go to our frog controller, we can say something like, if somebody hits the space bar, we are going to fire a missile. And I changed it to get key down, so we don't want them to just hold the button down and fire off a million missiles, so we'll say get key down, it will be space. And we will say fire missile, void, fire missile. And in here we are going to do something. And that's the exciting part that we're going to put in now. But first, let's take a look at what we want to have happen. We want to create a missile and have it just go up. As soon as we instantiate the missile, we want it to just keep going up. Sorry, I'm organizing my windows over here. Yeah, just making sure that I'm got my thoughts right. So what I'm going to do right now is we'll create a prefab of a missile that we're going to use later. And I'm going to drag in my missile, which happens to be this little wine jug thing, liquor jug, I'm not sure. And it's not an animated sprite, it just has one frame and it looks like this. So what we want to do is we're going to have our frog shoot this thing at these little robots. And I'm going to give, just like we gave a little bit of, if you want to call it AI to these robots, they know they need to go back and forth. This thing is going to have a little bit of AI on it as well. It's going to know that it needs to just go up until something happens. And so we'll practice with that, even though we're not going to have the controls in it right now. Oops, I don't want that, I want this. We can get our code working for this so that we know that it's going to work out. So we'll just call it missile. And we will create a missile script, missile controller. And if we run right now, we just see it sitting there. And what we want to do is, as soon as one of these things gets instantiated, we want to have it just go up. So with our missile selected, we will drag a missile controller on top of it, and then let's go edit our missile controller script. So it's going to be very similar to this frog, or I'm sorry, to the Crafty controller. Just inside of update, we want him to go up and off the screen. So let's see. We don't care about scale, but we just want to say position.y, because he's going to go up, plus equals, and we'll just say vertical speed. And that, and we will say public float vertical speed equals, I don't know, something like that. And now when we run, we should see our thing go up. Whoa, there it goes. That was a little fast, but that's all right. We can change that, right? We can go over here and say, this was too fast, so we'll say 0.1. How's that? Let's see. Does that make it go? All right, so that works. When that object is created, it goes up in the air, and that's good. So there's all sorts of things wrong with it, right? It's not tied to pressing the space bar. It's not colliding with any of these other guys, but that's okay. That's all stuff that we can work on. So right now, what I want to do is work on getting this thing to show up when we hit the space bar. And let me just make sure I'm not going too far off script here. All right, there we go. So anyways, let's do this. Let's think about what I'm doing here. All right. So I am going to create a prefab from this missile. We'll just drag it down here. That way we can use it later. So this is a prefab. It has this still associated with it, and also has the script. Because what we're going to do is in code, we're going to instantiate this object. So I can delete it out of our hierarchy, and then as we go and hit the spacebar, we're going to create this thing on the fly. And that's what we want to have happen. So if we go back to our frog controller, and we want to have a transform, public transform missile. All right, so this is we're going to be able to set what our missile is going to be. And then inside of our fire missile, we want to say, we need to create a new game object. And then we need to make sure we set the position to where our frog currently is. So it looks like the frog is shooting it with probably like a little bit of an offset. So it looks like it's coming from the front of the frog or from its little propeller. And then we just launch it. So let's say we want to create a new vector 3, which is our position. And this is the position of our frog. And then we create a new transform. Missile equals transform instantiate missile new, where are we putting it? New vector 3 position dot x position dot y and oops, sorry. Talking and typing is not my strong point here. Position dot z. All right, so we've created a new transform that is a missile, which we will assign up here later in the GUI, and we put it at position x, y, and z. And now that is really all that I think we need to do. If we go back to our code, instantiate takes 2 arguments. It does, that's what I have. Why is it complaining? No overload method takes 2. Oh, I see. Oh, and then I got to give it our rotation. So sorry about that. And we'll add our quaternion dot identity over here at the edge. So that gives us our third parameter. So this will help us know in 3D space where we actually are. Give it a position and then basically a rotation. And hopefully it's a little bit happier now. Yes. And let's take a look at our frog. And it has a missile here, which we should be able to drag our prefab onto. There we go. And make sure you drag the prefab, not the actual sprite. And then if we run, what happens? There it goes. Now we can shoot things. It may look a little strange, like it's, I guess it's coming from its legs. But that's okay. We're shooting stuff, and we can adjust the position as we need to, and fire stuff up out here. So we've got our little frog shooting things as we hit the space bar, and it's going up into our very crowded Space Invader screen. We do have a little bit of problems here with how they're turning around, and like I said, we can fix that, but that's not really the point. The point is to get them moving, and then they have some collisions with these things, and have some fun. So right now, things are working. Again, all that we really did is we created a missile prefab, called it missile, and then we instantiated a missile. And we could have even done this with one line of code. We didn't need to do this thing. We could say, instead of position.x, we could say transform.position.x. We made it one line of code, but that's all right. So we gave it the type that we're instantiating, which is a missile object that we defined up here. We gave it a position and a rotation, and then we're good to go. And yeah, it's complaining that, you know, we're storing this variable in M and then never using it, but that's all right. We will figure that out later. Oh, and then let's take a look at this. So we do have an issue though, and let me not maximize this on play. Show you what the problem is. So every time I'm shooting a missile, look what's happening over here in our hierarchy. It's like going out of control. And this is like grounds for a really severe memory leak, because every time I'm shooting a missile, it's just building up. No matter how many I shoot, there's more and more of them. See this thing scrolling? They're all existing in memory, and they're all, you know, driving. Like there's code that's executing, that's moving them up and off the screen. Even though they're way, you know, probably through the ceiling by now, there's still code that's manipulating those objects. And we don't want to do that. As soon as they're off screen, we don't care about it anymore, so we want to delete it. And let's see here. Let's go to our scene view. Basically, all that we really need to do is figure out the Y value of when things are going off of our scene. And I'm just going to grab my frog and move him up here. Y. I'm just checking our Y values over on this side. He's still on screen, so if I pull it up here, he's off screen, and the frog's Y coordinates right now is 6.4. So we'll just say when Y is greater than 7, that we'll consider it off screen, and we'll delete it. So we'll do that in our missile controller. Inside of update, we will say something like if transform dot position is dot y is greater than 7.0f, then we will destroy our game object. Make sense? So now anything that's way off the screen, we're going to delete it, and it's not going to stack up anymore. So we created these missiles, then they go away. Got a missile. As soon as it goes off screen, it gets deleted. I can try and do a bunch of them, and then as they all go off screen, they get deleted. So now everything is nice and neat in here. No matter how many I shoot, you know, we can only have basically as many active as I can punch on the keyboard for the amount of time it takes to go from here to here, which is fine. That's about as many as we would want to have anyways. No matter how fast I go, we're always cleaning up after ourselves, and that's a good thing. All right. Yeah, looking a little crazy, but that's all right. So yeah, so we created a missile prefab. Then in our code, we instantiated it. In the code for our frog controller, and the spacebar hit. On our missile prefab, we have a missile controller script which launches the missile straight up, and we also have one that cleans up after ourselves inside of the missile controller. If the missile makes it off the screen, then we delete it. And so that's pretty cool stuff. What we've got left to do is handle collisions. So when our missile hits our little guys, we've got to do something. Like, first off, we need to destroy the missile so it doesn't continue all through all of them. And then we need to delete our little, whichever particular robot got hit, he needs to get destroyed. We need to play an animation on top of that so it looks kind of neat. And then we'll add in some sounds, and that's all we got. So I think we'll continue this in a second. All right, so we've got our little game here, and now what we want to do is make our missiles actually hit some of these robot guys. And one thing that we need to do is we need to give a box collider to our missile. And we didn't do that before. Here's our prefab, and I'm just going to drag one of these into our scene so we can see what's going on a little bit more. We're going to add a component, Physics 2D, Box Collider 2D, to our missile. And here's our little rectangle, so I'm just going to make it adjust just a little bit. Bring it down a little bit. There we go. That looks pretty good. So there's our collider, and I've made it in this prefab. I'm going to come up here to prefab and hit apply, and that's going to apply it to our prefab. So I'll delete that out of there. And now, if we were to use this prefab, it's already going to have the box collider associated with it. So that's good news. So now it will collide with things, but our crafty bots, they don't have a box collider. So we're going to add one. Physics 2D, Box Collider 2D, and we should have made a prefab, but we didn't. So we will just go through all of them and add a Box Collider. Not an Edge Collider. There we go. And yeah, this is a little tedious, but that's alright. We don't have that many. If we had much more than this, I would delete them and just make a prefab, which probably would have been faster anyways, but that's alright. Alright. Component. Box collider. Collider. Oops. Collider. Yes, prefabs are nice. And box collider. And there we go. So now we have colliders on all of our little crafty bots. We've got a collider on our missile, and let's see what happens. Alright, nothing's happening. No changes. But let's put some code in. Let's go to our little crafty controller and put some code in to see what happens if we can detect a collision. So public void on collision, enter 2D, collision, 2D collision, say. Let's do this just to make sure that we're actually detecting collisions. And we don't see any messages in here. So it is not, something is amiss. We can try, let's see. The problem is, I think we need to give some of these things a rigid body. And if we do that, then I think it will probably work right. But yeah, let's go through. What is this? Is trigger? Does that work? Probably not. No. So we need to add a rigid body to all these things. And if we do that, then everything is going to work. Hopefully we'll be able to detect our collisions. But we'll go through and add one to each of our little crafty bots. And yeah, it's going to be a pain, but that's alright. We'll add physics 2D, rigid body 2D, and the thing is if we give it a mass and gravity, let's see what happens if we go to play now. That guy's just going to fall down, right? So we need to give him a mass of 0 and a gravity of 0. And then when we run, it's going to stay in line. So we're going to have to go do that for all of our guys here. And then we should be able to detect our collisions. Yes, this is boring, but it's okay. We can put up with boring for a few minutes. Anything more than a few minutes, we write code to do it for us. And we're almost done. No, 5 left. Alright, so hopefully you created a prefab because you got bored, but I didn't. So anyways, now we have this, and we're seeing all of our collision, and look at this, we are doing all sorts of fun things. Okay, so we are making progress. It's not what we want, because we want to delete our missiles and delete our little crafty bots as soon as there's some sort of collision. So we can do that, and we can do that pretty easily. Now that we detected the collision, inside of here, in this onCollision inner 2D, we can, this is for the crafty bot, so we can say destroy game object, which will destroy our crafty bot, and the other thing we can destroy, call.gameObject. And that is our missile. So now when we run, look at that. Now as we hit these things, they disappear. They're actually disappearing from over here as well from the screen. And so that's it. We just made a nice little shooter game where we can make things get destroyed. If we do it again, do this. So there really wasn't much that we added. We added box colliders to the missiles and to our crafty bot, and then we added a rigid body to our crafty bot so that we could detect the collision, and we changed the mass and the gravity scale to make them 0. That way they're not going to fall down, due to gravity. They're just going to stay in their current position. So that's one way to detect these collisions, and it works pretty good. All right, so now what we're going to do is we're going to play a little animation of a sort of like an explosion. Although we're just going to use a star because that's the closest thing that I could find to an explosion. When our little missile, our little still runs into one of our guys. So in order to do that, we need a few things. One of them, of course, is a star, which is here. And if I drag that into our scene, where did it go? Here it is. So here's the star that we're going to sort of, show as an explosion. I'm going to make it a little bit bigger. It kind of looks weird, but that's okay. We want it to completely cover up our little crafty bot. That way it sort of looks like an explosion is happening. So that's why I'm going to make him so big. Now let's rename this thing to star. And what we want to do is we want to have, when there's a collision, we want to draw this star on top of our crafty bot that's exploding. Then we want to destroy our little crafty bot, and then we want this thing to fade out. And if we do that, it'll look like there was sort of an explosion happening. So if we run right now, this isn't overly exciting. There's just this star sitting right in the middle of our screen. And what I want to do right now is practice a little bit with this star to see if we can get some code that makes it fade out. So I'm going to create a new script called starFade. And we will attach it to our star object, and then we will edit it. And what we're going to do is we want to fade. All we're doing is changing the transparency. So every pixel has a RGB and an alpha, red, green, blue, and an alpha value. And so we are going to just change that alpha value of our star and just fade it out over time. And so we're going to have a couple things here, variables that we're going to use to do this. Public float min equals 0.0f, public float max equals 0 or 1.0 float. So we're, this is our min and max transparency levels, and then we'll have a duration. We'll play the animation for a half a second, and then we will have just a private variable float start time. So we keep track of how long we've been in here. So as soon as this star gets instantiated, we'll set our start time. So start time equals time.time. And then inside of update is where we'll actually handle our fading. So we'll say float t equals, so we're going to fade from, we want to actually fade from 1, which is a solid pixel, all the way down to 0, which is completely transparent. So we'll say float t equals 1.0 f minus time.time minus start time divided by duration. So we're just trying to get, how long have we been fading, and so what portion of this from 0 to 1 are we supposed to be at? And then we need to get the color and change it, and then we're done. So we'll say GameObject.getComponent. We want to get our sprite renderer. Sprite renderer. Dot color equals new color, and we'll say 1f 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 comma. So we're saying we're leaving the color at 100% of the RG and B, whatever they were before, and then we're just going to change the alpha. So we'll say math f dot smooth step min max comma t. What percentage have we gone through? And that should be it. So let's see what happens. Okay, did you see that? It kind of went fast. So I'm going to, let's see, our star object, I will change our duration to like 5 seconds. And now it's fading out over time. And that's, a really slow fade for an explosion. So if I put it back to 0.5 and then we run, so that looks pretty cool. One thing though, our star is still alive somewhere in here because it's completely transparent, but it is still alive. So one thing that we want to do is make sure we delete it. So when t gets down to 0, we need to delete our object from the scene. So if t is less than or equal to 0.01, some value, we will just say destroy game object. So once we're all the way transparent, get rid of it because nobody can see it anyways. And so if we run our game again, notice how this thing deletes after a half a second. Now it's gone. That's because it went completely transparent in our code. We told it to destroy itself. So I am going to, for right now, save this thing as a prefab. So just drag it down. Now it's a star prefab. And I'll delete it from our scene. And then all we need to do now is instantiate in code, just like we did with the missiles. But we're going to instantiate a star on top of our little crafty bot whenever there is a collision detected. So if we go into our CraftyBot controller and we will say on collision enter 2D, we need to instantiate our star. So we can instantiate All right, so we're going to instantiate our little star. Instantiate star, and it's going to be at our position. And our rotation. All right, this is going to be star, not start. And actually, we should probably need to define it up here. So public game object star. So we're going to have to drag this thing in later on. So that looks about right. Let's see what happens now. So now if we go here and we have our crafty controller script, it's now looking for a star, and we can drag our star in there. And you know what? I am just going to delete all of these things because I want to use a prefab. There's our crafty guy, and he's got a star, all this stuff, everything's good. That way, when we make all these changes, I don't have to go through and keep doing it. We'll use a prefab. That's what we should be using anyways. So yeah, create a prefab out of him, and let's make some more. Another one. These aren't very straight. And then for simplicity's sake, let's just go with these guys. And now we've got everything is lined up since we used a prefab. So let's see what happens. Probably should work. Oh. Not good. Crafty is not valid. What did I just screw up? Well, let's troubleshoot this a little bit. Game controller? Is that what it's mad about? Very interesting. Null reference. Horizontal speed, game controller. Maybe it's complaining about our game controller. Let's see. Ah, here we go. Game controller wasn't set in these new prefabs for whatever reason. No big deal. Just drag them in. And let's see what happens now. There we go. And now if I shoot, there, look at that. Perfect. Very neat. So now we have our little star coming in and fading, and that looked awesome. So yeah, sorry about that little delay there. These guys didn't have their game controller script assigned to it, so I just had to do that real quick. One last thing, I want to make that star look a little bit better. So let's go back to our crafty controller. And here we instantiate our star, and everything looks cool. And in our star fade, I want to make it just do like a little twist. And so we're going to do a rotation of our star. So we're going to get the rotation. It's in quaternion. the z value of the quaternion. Q equals transform dot rotation, and we'll say q.z equals math f smooth step, just like we used before, min max t, and transform dot rotation equals q. And so these three lines here are just going to make us do a nice little rotation. And I think, I'm not really sure, but I think this thing might be in radians, and so we get a nice little cool looking little squiggle thing when it runs. We'll twist back and forth. And now we've got an awesome looking game. This is something that I would love to play if we had a score and some sounds. So I think next what we'll do is we will add in some sounds, and then that's probably going to be about it. We can add in scoring, but we all know how to do that. We can add in different levels, but we've already done all that before. So I just want to keep these tutorials to things that I haven't talked about in the past, and for the most part anyways, not essential things. So we will go through and add in some sounds next. We'll add in a sound when we shoot our missiles, and we'll add in an explosion sound when these things get hit. And I think that'll be it. So we'll do that in a second. Alright, so now we are just going to have a little bit of fun with sounds, and then we'll have pretty much a completed demo game as far as what we wanted to do for shooting objects. And sounds in Unity are actually pretty simple. So I'm going to drag in two MP3s, hit and shoot. And here they are. They show up in here. One of the things to look at, though, is that every time you drag in a sound, by default, it gets set to a 3D sound. And in 2D, we don't want that. We want it to always just play, and it doesn't have to worry about position of the character and all that sort of stuff. So we're going to uncheck 3D sound and hit apply. And make sure you do that for all the sounds that you're importing in your 2D games. Alright, and we've got two sounds, a hit and a shoot. And this actually becomes really easy. Because think about this. Let's do the hit one first. We want to play this explosion sound. Does it play? Alright, that's our little sound we're going to make when we actually hit one of our robots. And if you think about it, as soon as we play the star animation, we want to play this hit sound, because we're playing the star animation when one of these guys explodes. And so all we really need to do is attach this sound to our prefab over here, and then it should just work. So if I drag it over there, we're going to get an audio source, and play on awake is checked, which is good, and that's really it. And so if we run, it should just work. Alright, and so that was easy, because all we did is play this sound, play on wake. If play on wake is checked, as soon as we instantiate a star object, it's going to play the noise. And we're only instantiating the star object when there's an explosion, so that's what we want to have happen. And along the same lines with the missile, we want to play our shoot sound whenever we create a missile, play on awake, and if we play, there we go. So now we've got a game with sounds. And that is super exciting. So we know how to add scores, we know how to add levels, and all that kind of stuff. We can make this into a more exciting game. We can change the speed of these guys as there, gets less and fewer and fewer of them. There's a lot we can do. Make a different animation of this guy when he's shooting, things like that. But for this whole purpose of this tutorial was to go over creating some guys who can walk back and forth by themselves, creating projectiles, making them connect with other guys in our scene, having an explosion so that we can delete them and make it look nice. We drew the explosion, and then we added in sounds, and that was our intro to sounds. And so I think that's all that I really wanted to accomplish for this tutorial, so that'll end it.